Alright, today is June 2nd, 2022. It is a Thursday, and today I am up to the inference analysis part of my research, not my research project, my data project for statistics. Also, it is day 319 of data science, and it is also log 3 of this research process. I haven't even been posting the videos. I don't know. Anyway, yeah, so today I'm going to be calculating a confidence interval for my data over here. So again, just a reminder, what I did was I basically conducted an experiment to see the effect of the angle that the catapult was placed on the distance traveled by 30 gummy bears. And so these 30 gummy bears, I had them launch on a catapult placed in a 45-degree angle, which is treatment 1, and also a 60-degree angle, which is treatment 2. And then as you can see, that's the data that I made in using Python with pandas, and then I uploaded it to I downloaded it as a CSV and then uploaded it to Google Sheets, and then I made it pretty, right? So I made like the borders and the blue and the whatever. And now I'll walk you through what I was thinking at school. So because I have to conduct a confidence interval, I was either thinking like matched pairs, right? Because matched pairs is when you have basically your experimental unit. In this case, our gummy bears are experimental units. So basically, you can think of experimental units as your subjects, which are our gummy bears, right? And so each experimental unit is exposed to or undergoes both or all treatments in any experiment. So sometimes it's a control, like they go through the control and then treatment 1. But in this case, I don't have a control group. I have just treatment 1 and treatment 2, which is the catapults placed on a ramp with a 45-degree angle, and then a catapult placed on a ramp with a 60-degree angle. And then I had launched those 30 gummy bears each, in the respective angle. And so I got the data that I got. So, because the gummy bears went through both treatments, they were the same gummy bears, it makes sense to do a matched pair confidence interval. And so, matched pair confidence interval, I believe, is a one sample t-test, because we're dealing with means. Not t-test, t-interval, because we're dealing with means. So this is, one sample t-interval the purpose is to capture the true mean difference? Because for matched pair, let me give you a visualization. So you would take your one column. So for me, it's treatment 1, and then I have treatment 2. And so, for example, let's say you have this data value, like let's say A and B. You would do A minus B, and then you would get, like, let's say C. And so you would add up all of these differences, because these are your differences. And then you would take the mean, right? You would take the mean. And so this is your mean difference, your average difference. So the average difference, how do you say it? Your average differences? The average of your differences. And so that's what matched pair is, to find the mean difference, the average difference between the distance traveled, in this case, by the gummy bears. And so I kind of, just for a reference, because for me, I rarely, like when I was studying stat, learning it, matched pair was something that I did like once. So like I barely know or remember really like the process. So I came up, like I Googled like an example. And so it is a matched pair t-confidence interval. Again, so they gave us an example. They basically took the difference between like 7.3 minus 6.9, you would get like 0.4, and then they took the average of all of those differences, right? And that would be their data set. Check conditions. So the first thing, where did my stuff go, that we're doing is checking conditions. So for conditions for a matched pair, what interval would be, the first thing would be that it's random. Actually, they're essentially all the same, kind of. It's just sometimes it's different, slightly different. So random, so the sample has to be random, so like a simple random sample, etc. of gummy bears. Then we have the 10% rule, if I remember correctly, and independence, or normality. No, wait, hold on. 10% rule is independence. Normality. So 10% rule usually is when n, the sample size, is less than or equal to or 10% of the population. Normality is when n for means is, I believe, greater than or equal to 30. I'm thinking, let me think. N is greater than or equal to 30, yeah. Okay, so I'm going to use Python to just check these. Also, I'm just walking you through my thought process right now. So I was thinking, if I use matched pair design, and if you take a look at my data, let's go back. Where's my stuff? So this is what my data looks like once it wants to load. You can see that column B, right? Those are my subjects. But in order to match pairs, I have to have the subjects in like order, right? Because I'm taking the difference between each gummy bear, but like it has to be the same. So, like, how do I say it? It has to be the same gummy bear. So basically I just have to order these in order, so that when I take the difference of subject 3, I take the difference of subject 3 here, instead of doing like subject 3 minus subject 18 distance traveled. I can just do subject 3 distance traveled minus subject 3 distance traveled in treatment 2, if that makes sense. So I'm not trying to do the distance traveled between subject 3 and 18. I'm trying to do 3 minus 3 in both treatments, right? So in order to do that, I'm not going to use Python because I can easily do it so fast right here in let's see, in Google Sheets. So sort, where did this stuff go? Data, sort range, and then sort range by column A to Z. Whoops. So let me do this. Let me just select these. Alright, and then data, sort range by column A to Z. And so, whoa, no, the other way, excuse me. A to Z, right, okay. So now you can see that it's sorted, and then you can see that this is an issue. Wait, hold on. In order to make sure that these go along with it, because we want them to be the same, I'm going to select both of them, and then like both columns, and then do data, sort range, A to Z, and now they're good, right? So that's good. And I'll do the same for this one. I'll do data, sort range from A to Z. So now we're good. So this is the data that I want to use, basically. All right, and then at that point, I want to now take the difference between each of them and then make that its own data thing. So I think I'm going to download this as a CSV. What I think, what I'm going to do? I'm going to just duplicate this and then delete all of this, just in case because I don't want that in the CSV. Not that I've never done this before, like this downloading from an Excel. This is like the first time that I use Google Sheets. Not really, like I used it in 8th grade, right? But like I don't, just to like plot a graph, like I don't know, like I've never used Google Sheets. CSV, yeah, right here. Okay. So I should download, and then I'm going to go here to data science, and I'm going to go to my files, go to that little thing, go to downloads, open that up, right click, copy path, and then I'm going to go here. I'm going to do import pandas as PD so that I can read in my data. So PD dot, what was I going to do? PD dot read CSV, right, because it's a CSV file, and then just paste that in there, and then I'll run that, and then you'll be able to see, wait, hold on, data dot head, the first 5 rows of the data set. Okay, Unnamed. What is this? Oh, it's because of the columns. Okay, so let me fix something real quick. This is why I made a duplicate. So let me delete all of this. How do I delete it? Hello. All right. Oh, but here's the thing. It's different because, it's not the same. Actually, it is the same. Yeah, it is the same. You know what? I could just do, since I have it in order now, I can just delete these two columns and this one too, and then just take the differences between each one, or like maybe loop over them. I don't know, man. So let me delete column, delete the column, delete the column, and then delete these rows. Alright, and then I'll download this data and see if that works better. So CSV, go back over here, go to files, delete this one, and then upload file, and then upload this one, see if that works better. Copy path, paste that in there, run that. All right. Oh, wait, no, because then, yeah, I'd rather fix this here. So let me go and right click, insert, how do I do this? Insert row above. And so I'll call this, treatment 1, and then treatment 2. And then I'll download again. Where is it? Okay, download CSV, go back here, delete this. No, delete the file. Upload. Is this it? Is it? I think. Okay, right click, copy path, paste that in there. Whoops. Okay. And then let me just see how it looks like. So data.head prints out the first 5 rows. All right, perfect. So this is what we have so far. Now it's in order. Now what I'm going to do, I'm going to try to do this. Hold on, let me think. How can I do this? I want to take the difference of everything. So I'll do, let's say, the mean, the differences, right? I'll take the differences and I'll set that equal to, ew, why is it capital? So differences equal to, no, I'll just make data, and I'll make a new column called differences and set that equal to, I don't know if I were to just do treatment 1 minus, I don't think that works. I don't think it iterates over. It's probably not gonna work. I think I'm gonna have to do for loops. Let me see. Oh my god, did it work? Wow. Hold on, let me try. So 166.370 minus 137.160. 29.21. Oh wow, it did work. Okay, thank God, because I did not want to do some for loops today. Okay, differences, and then I'll actually do head. So it only prints out 5 rows, and then what I'll do is I'll just take the differences column, and I'll just take the mean of it, right? And I'll set that value equal to a variable called mu difference, right? So the mean difference, and then I'll print that out, and then that's the difference. That's the mean difference. That's the average difference. So let's think now. Now that we have that, let me go back. So I'm just thinking, I don't know. Let me see. So confidence interval is point estimate plus or minus margin of error. Point estimate is the mu difference. So I'm going to try to do this. Wait, I haven't even done the, I'm all over the place. I haven't even checked the conditions yet. Let me think. Let's see. What am I gonna do? Think. Alright, so let me go to my whiteboard. So the first, let's check the conditions, right, before doing that. So random SRS, well, yes, our gummy bears were randomly selected. So this one is good. It's an SRS of 30 gummy bears. 10% rule. Is our sample size less than or equal to 0.10? And well, we can check, right? So our sample size is 30. So is 30 less than or equal to 10% of all gummy bears? Right? That's the question, and that's going to be yes, that's reasonably true. That I'm pretty sure there's more than 30 gummy bears in the entire world. So yes, that's reasonably true because we don't know this size. This is capital N. We don't know the population size. Okay, and then this condition is checked, and then normality. So normality, 30 is greater than or equal to 30. Well, yes. So that's good. So we can go and perform our confidence interval. Now, let's think. But it's not, what we're calculating, the data that we're calculating is this right here. And in Python, it's our differences column. That's the data we're working with. That's why it's a one sample t-interval, because this is from one sample, and we're not doing two samples. So we're not doing like two sample t-interval. We're doing one sample because we're just working with the mean difference. Not the mean difference, the differences, right? The data of the differences. And so that's why we're only doing like one of them. Instead of checking for both of them, we're actually doing this one here. So the sample size for that is 30. Alright, whoops. This thing is not working. Alright, so that's, okay, I'm like literally really all over the place. So when you think of confidence intervals, you want to do panic. So I already did A, which is the assumptions, or you can call them conditions. The parameter, right, is mu, well, no, hold on. Yeah. Is the true mean difference in distance traveled by gummy bears between like the true mean difference in distance traveled by gummy bears. Actually, yeah. With between, how do I include treatments? The true mean difference in distance traveled by gummy bears. Difference in distance traveled by gummy bears. I think that's fine. So we did A, so we checked the assumptions. N is the name of the procedure that we're doing right now, and so this is a one sample T interval for mu difference, or the mean difference, right? And so why T? Because T we use for when we're working with means. So that's why we're using T. We use Z when we're working with proportions. Okay, then I stands for the interval, and interval always starts with point estimate plus or minus the margin of error. So the point estimate is always your statistic. So in this case, our statistic is our mu difference, our mean difference, plus or minus the margin of error. So the margin of error is T star times the standard deviation, well, the standard error of the data. So hold on. What are we doing again? So one sample, two. So T star. And then I believe it's x over square root of n. Let me just check. Let me reference what they have here. Yeah. The point estimate plus or minus d star times s over mu. Right. Okay, perfect. So let me go back. What am I doing again? All right. So that is that. So what is the mu difference? We already calculated it. So we did that part already with Python. So the mu difference, the mean difference is this. I don't know if I want to use... Okay, so what I'm going to do, as I'm writing in the whiteboard, I'm going to round it to negative 0.9313. But when I'm actually performing the calculations, I'm actually going to be putting the entire number in because, yeah. So then I'll do... I can barely see the pen. Here we go again. The pen doesn't want to show up. Great. Amazing. Okay, 1 second while this thing decides to fix itself. And I still can't see it. What is going on with this thing? Is it my mouse? I'm so confused right now. Alright, so when we have a problem, what do? We Google the answer. Okay. Why is my cursor not showing up on whiteboard? App. HP. No, not Microsoft. Like, what does this thing want me to say? Okay, well, this is not giving me an answer right now. This is so frustrating. Like, see, it appears and then it disappears. I'm literally so confused right now. Like, what? This is so frustrating. Why? Why? Out of all days, why today? Oh my god, I'm gonna cry. What the heck? Okay, let me open this up on my desktop then. on, not my desktop, what do you call it, the browser. So I'll copy the link, and then I'll go over here and just paste that in there. Oh my god, okay. Alright, hopefully it lets me right here. Alright, so this is so far what we have for our interval. Thank god I can see it now. Alright, so it's plus or minus t star. So t star is actually 1 minus alpha divided by 2. I'll explain that in a second. And then I have the degree of freedom, I think. That's what it's in. Let me think. T star. Let me see. Does it have T star here? Where's T star? T star is equal to what? Let's think. It doesn't say here. Okay, whatever. So I'm pretty sure that's what it is. Degree of freedom is n minus 1. Wait, it's n minus 2 for linear, for LSRL. Okay, but n minus 1 always for this. Okay. So alpha is your confidence level. So this is your confidence level. So how confident are you? I'm going to be performing a 95% confidence interval. So my alpha is going to be 0.95. So it's going to be 1 minus 0.95, divide that by 2, and then degree of freedom. Oh, by the way, the function that we're using in our calculator is inverse t. Our degree of freedom is going to be 30 minus 1, which is 29. So inverse t that, plus or minus negative 0.9313. And then our standard deviation, we're going to have to get. So we can go back to our data science file, and then what I'll do is I'll just do udiff, and I'll do data, and I'll do differences, and I'll do s.std, and it should give me the standard deviation once I tell it to, whoops, my bad. Wait, what did I do? Differences, standard deviation. Wait, is that what I did? Yeah, right? Okay. So this is 48.8605. So 48.8605. Where did my... Okay. 48.8605. So 48.8605. Is that what it was? I forgot now. Yeah. So, and then it was 30 for sample size. So again, this is the standard deviation. It's this. And then this, whoa, what was that? Right, is T star. And then the mu difference is this. Right? Okay. Let's think. So what else do we have to do? Just calculator, right? So, let's think. I already have a function for this. I already wrote one, so let me just search it up real quick. I think it's in this one over here. Let's see, confidence interval. I have to do something real quick. So let me go here, and then just wait. So I have for proportion, but I want one for mean. Yeah, this one's for mean. I need one for proportion. For proportion, confidence interval. There we go, beautiful. But that's no, I only need one sample. This is 2 sample. Well, 1 sample is the same thing except without all that jazz. Hold on, let me find my stuff. 2 sample t interval for mean. I'll just copy this function and just edit it. Alright, so I'll go out here, Oh dang it, I should have, oh no, I'm so irritated. Let me go back to 13. I should have found the T star. Oh, they have T star. Okay, perfect. Okay, great. So we'll go back here and I'll go and just put that in there. So we're doing a one sample T interval for mu difference. And so that only requires just one of these. So we'll just do n, the actual mean, which is just, we can think about it as u diff, the standard deviation, and the confidence level. So over here, I'll literally just change the function and then put my data in. So again, my n is 30, right? And we can get that by getting the length of the data of, let's say, just like differences, right? U difference, again, is data differences, and just get the mean of that. Standard deviation is data, differences, and just do .std, and then the confidence level is 0.95. And then let's see the mean difference. So let's think about this real quick. So the df is literally just n minus 1. Wait, why is it 1 is 2? Is this n2 minus 1 or n1 plus n2 minus 1? Nah, bro, it's just minus 1, right? Let me double check. So let me think. T star. I have it. Let me look at my notes. I have. Whoops, what's going on? I don't think I ever got to T star in these problems because I remember not having the calculator and I had used basically the Python. I meant Python, period. I need a good example. What is this? No. What is this one? The mean? No, this is mean difference. I mean difference in means. I need a mean difference. What is this one? The true mean. Yeah, this is a one sample. Okay, perfect. What is T star? T star is 35. 1 minus 0.90 over 2, 35. Oh, it's minus 1, right? Right, because df is, oh, here we go, n minus 1. Perfect. Okay, just wanted to double check that. All right, so where were we going? Okay, so df is equal to n minus 1, so no need for these parentheses here. Q, which is basically the first parameter, so it's basically inverse t and then qn, so that's what we call Q. It's 1 minus the confidence level divided by 2. T star, it's stats.t.ppf, and then Python takes it in different, it takes in the opposite. How in the world does this work? That's funny. Okay, so so for the margin of error, the margin of error, it's not the margin of error, this is the standard error, is just math.square root. It's not, hold on, okay, this is so for this one, it's, in parentheses, you have sx divided by math.square root of n, and then endpoint is mean difference, which is just u diff. It's not mean difference, it's difference in mean. So it's difference in mean minus that, minus plus that. And then, alright, I think that's it. So then let me put in Length takes exactly one argument for our given. Did I not close it? Whoops. Close parenthesis. Alright, so what's the issue now? There we go. Difference in mean, margin of error is not defined. Where did I have it as? This is supposed to be SE. Because margin of error is actually, hold on, wait, no. The margin of error is equal to T star times the standard error. So yeah, this was supposed to be margin of error, right? Because at the end of the day, it becomes your point estimate plus or minus your margin of error, right? So that's what it is. All right, so great. What is it now? Do we want to, let's see, let's think about this. Here is your 95% confidence interval for mu1. Oh, it's not mu1 minus mu2. It's for difference in means. But then it's not giving me an answer, so that's an issue. Okay, so let's think about this. How can we fix this? So the length is 30, right? So I'll set that equal to n. And then we already set this equal up here to u diff and diff standard deviation, so maybe I'll just do that. And then the confidence interval. No, because I don't want it to be like that. Hold on, I'm confused. What am I doing again? I'll just delete these here. So I'll take this and I'll put this in over here. Well, no, because I want this to be general. Let's think. You know what? It doesn't even have to be general. I don't care anymore. Mu difference is this. Alright, and then difference standard deviation is this. So that's going to be my STD. That sounds wrong. And then my confidence level, I'll do N, U diff, standard deviation, 0.95. Oh my god, what's the issue now? Oh my god, why? Why does it keep giving me a no answer? What am I doing wrong? Probably has to do with this. Data. Degree of freedom, n minus 1. Oh my god, Kara. Americans interpret a confidence interval for the mean weight of an Oreo cookie. So one sample T interval for mean. Fixed version on day. Oh, so it wasn't fixed. I knew it. But that's what I did, didn't I? Was it not close enough? What did I get for this? Okay, I got 11.3691, 11.4151. Okay, that's good. So then it's reliable. So let me again just edit this function then apparently. It's the same thing. So this is what I wanted, yeah. So in this case, it's literally the exact same thing. Oh, the absolute value of G star. Whoops. Alright, so this is for difference in means. And then I actually have to put in my values. So for this one again, is going to be 30 U diff standard deviation, and then 0.95. There we go, it just did it for us. I didn't have to calculate it, but basically I just wanted to show you how to calculate each individual part. So let me close this out. Wait, hold on. No, let me start from the beginning. Let me run and make sure everything is fine.